Well, hello there! I hope you're having an amazing day and that you're feeling as excited as I am about our today's topic, because today we are talking about arithmetic operators. At least the basic ones. This should not be too difficult of a lesson, but it's probably going to be a lengthy one. So sit tight and enjoy the ride. Great! So what is an operator? Okay, operator is a symbol that is supposed to tell our compiler that it is supposed to do some action or to perform some process on our operands. And when I say operands, I basically mean variables or values that we are operating on with this operator. So basically, to put things in a more simple manner, operators are symbols that we use to tell our compiler that it's supposed to do some action on some variables or values that we are working on. So in Rust, we have 5 basic arithmetic operators, and today we are going to talk about all of them. So the first operator we are going to cover is going to be addition. So for addition, the operator symbol that we are using is, of course, a plus sign. And it's a binary operator, which means that we are using it on 2 different values. So in order to use plus operator, we need 2 values that we are going to add together. So that is why it is called binary, because 2 operands are needed for us to be able to use this operator. It's as simple as that. The second operator is going to be subtraction. And this one is again very simple one, and we should use minus or a dash character to indicate to our compiler that we want to subtract some value from some other value. So basically it's a binary operator again, because as you probably can already guess, the second value is going to be subtracted from the first value. So exactly the same as we are used to using minus operator in math. So the third one is going to be multiplication. So for multiplication, we need 2 operands again, and we are going to be using asterisk character to indicate to our compiler that we want to multiply 2 values that are stored inside of our operands. And the last basic operator that we will be covering today is going to be dedicated to division. And to indicate to our compiler that we want to divide 2 numbers, we are going to be using slash character. And again, division is binary operator, so we again need 2 operands in order to perform division, because we need to divide first operand by the second operand, and that way we get the result. But here I want you to remember that we are talking about division without remainder. This might not mean too much to you right now, but just try to remember it, because when we get to the point where we are talking about division in practice, it might be great if you remember that we are talking about division without remainder. And that's it, we covered all the basic operators in Rust. Hey, I thought you said we were going to talk about 5 operators, not 4. Can you even count? Ah, thank you for reminding me. I'm so silly. I forgot completely about our 5th operator, because it's a bit different from what we are used to when using operators. This one is a bit less common in real life when compared to others. But again, you will see that in action. And the true last operator that we're going to cover today is called modulus. And basically, it gives us the remainder of division of 2 operands. So basically it's again binary operator, so we are using it on 2 operands, and it returns the remainder of division of those 2 numbers. Again, this might not mean too much to you right now, but you will see it in action, and hopefully it will all start making much more sense. And because of that, I feel like we should visit our Visual Studio Code environment because there we are feeling hyper-focused and eager to master these concepts. I'm sure of it. I really cannot wait any longer. Let's jump right into Visual Studio Code. Ah, such a nice environment. We feel so relaxed and safe here. So right now we can just start learning and extending our knowledge about basic operators in Rust. Let's start by opening a new project that is going to be dedicated to this video, and let me show you what I have prepared for you inside of it. Of course, I'm going to try to explain basic operators, the ones that are very simple and straightforward, as simply and quickly as possible, and just maybe point out some potential problems and potential downfalls that you may encounter while using them, and I will try to explain the ones that are a bit more complex and not as simple as we may expect in a bit more detail. We will be starting things off with a simple examples just to get warmed up. So we will be starting with the addition. The first example you can see right here is just a simple adding of two numbers and getting the probably expected result. Okay, before we get started with the actual discussion about adding two numbers, I want to tell you about the println macro that you can see here, because I want to explain to you what is actually going on here. As you can see here, we have three squiggly brackets, and you can basically think about squiggly brackets as placeholders that will be replaced by the respective value that you can see after the quotation marks followed by a comma. So basically, you can see that for a first squiggly bracket, we have x variable after the quotation marks. And for the second squiggly brackets, we have y variable. And for the third one, we have x plus y. So basically, we are just going to get x plus y is equal to x plus y result. So this should be just a basic explanation about println that we will be using in this video, so I want you to understand what is going to happen here. Okay, now when we add 15 and 130, we should get the expected result, right? So 145. And when I run our program, we indeed get 15 plus 130 is equal to 145, which is exactly what we wanted to get. Okay, let me uncomment our second example quickly, and I want you to pay close attention to the data types. As you can see, by default, the data type that is going to be inferred by our compiler is going to be i32, which is, as you already know, the default data type for integral numbers. And I want to update the data type of the second variable to u16, for example. And when I save the file, you can see that the inferred data type for the first variable was also changed. It's now u16, because if you think about it, it would not make too much sense to be able to do operations on two variables of different types, because the sizes and the way that those numbers and results are being calculated are different. I mean, they may be different. So that is why our compiler is going to infer the data type for our first variable to be exactly the same as the data type for the second variable, where we were explicit and wanted to specify u16 as a data type. And now, if we run the code, everything works as expected, we get the same result, which is 145. Okay, let's jump right to our third example. And here, I want you to remember that our u8 data type range. So remember that the range for u8 data type is from 0 all the way to 255. So when you take a look at this example, I'm trying to add 15 and 255, which is going to exceed our 255 limit. And when I try running our code right now, we will get an error. Our compiler is going to tell us that an overflow has occurred. So what is overflow actually? So overflow is something that happens when we cannot fit the value that we should fit in our variable inside of it. So when you specify a data type for your variable, you have basically limited the value that can be stored inside of that variable. Because we will allocate a certain number of bits for that variable, and you cannot exceed that limit because the memory is already allocated and more bits are not allowed. They're just going to be lost, so to say. And that is why our compiler is going to scream at us right here, because we are going to exceed the limit that is supported by the data type of U8. So if I just, for example, lower the value to something like 240, and when I execute again, everything should work and we should get 255, because that is the upper limit that is supported by U8 data type. So it's not the problem in the fact that we are using U8, the problem is in the fact that we are exceeding the maximal value supported by it. Our second operator is going to be subtraction. And to test it out, let's use the same numbers as in the first example. And when we subtract 130 from 15, we should get minus 115. And when we run our code, that's exactly what we are getting. Because this is completely fine result, because we are using signed integer. So we can use and we can get negative values, and that is not going to be a problem. So we can jump right to our second example. In our second example, I have changed the type and put the explicit U8 data type for both variables. And when I try doing the exact same thing as we did for I32 in third data type, we will get an error, because U8 does not support negative values. It's an unsigned integer data type. And we will be getting minus 115. And when I run the code, we get exactly the same error as we did in the previous scenario, where we exceeded the upper limit of our number when the result was above 255. Right now we are getting exactly the same result and exactly the same error message when the resulting number is minus 115. And that makes sense, because the range is again exceeded, but this time in the negative part, so not in the positive part. So bigger than the maximal value, this time it's lower than the minimal value, which is again an overflow. Of course, if I were just to change the order of our variables, so if we subtract x from y, we will be getting results perfectly fine, because x is smaller number than y, and we will be getting 115 as a result, which works perfectly fine because it's within the ranges of U8 data type. Okay, let's jump right to our multiplication operations. And the story here is fairly straightforward, and you should only pay attention to the fact that when you multiply negative number with a positive number, you get a negative number, which you probably already know from the real life. And also you should pay attention not to overflow the limits of your data type, because multiplication can get you there much quicker and easier when compared to addition and subtraction. Okay, let's start with a very simple example. We're going to multiply 5 and 30, and when we run our code, we will be getting 150 as a result, which is exactly right. Now let me show you how easy it is to actually get an overflow. I'm going to explicitly state the data type for our variables in the second example to I8, so signed integer but 8 bits long. So we have the range from minus 128 all the way to plus 127. And if we use exactly the same numbers as in our previous example, we will get 130, which is an overflow, if you remember, because the result 130 is greater than 127. And we get the same error message as we did before. So just keep that in mind. And now that we're done with covering the first two operations, it's time to talk about division, because division can mislead you in some areas. So pay close attention to the examples and you should be good to go. In our first example, we have the same numbers. We have number 30 that is going to be divided by number 5. And when we run the code, we get the expected result. We get number 6 as a result, which is completely right. I have no idea what is complicated to you here. This is all so basic and simple. We learned about division in elementary school. We'll see. Okay, let me try to change your mind. In our second example, we have 31 divided by 5. What do you think is going to be the result of this operation? If you said 6, you were right. Because when we run the code, we will get number 6, not 6.2, which is the correct value, we get just 6. But why is this happening? Well, that is because the data types that we are using for our variables is integer data type. So we can only store whole numbers. We cannot use real numbers. So basically, in these scenarios, our compiler is just neglecting these parts that are basically not divisible by the number. Okay, let me show you that it's only because we are using integer data types that we are not getting the remainder of our division. So if I change the data type in our next example and put F32 as the data type, and we divide exactly the same numbers, so 31 by 5, we will get 6.2 as a result. So let me show you by adding number 34 and dividing it by 5. Because if you think about it, if our compiler was rounding up or rounding down numbers, we should be getting number 7 as a result here. Because when we divide 34 by 5, we get 6.8, which is closer to 7 when compared to 6. And when I run the code, we get 6, not 7. Because our compiler is just neglecting this remainder part. And I hope that now you have a better understanding about the reason why I said that division is a bit more complicated in some areas than you might expect. And now we can finally discuss our last operator for today. So I'm talking about the modulus, or the operator that is returning the remainder of division. So let's jump right into some action. I'm going to kick things off with exactly the same example that we used in our division part. So I'm going to use 31 and then calculate the modulus by number 5. And when I run the code, what do you think we will get? Do you expect to get 0.2? Or do you expect to get what? What is it that you expect to find here? Think about it, write it down, and then when I actually run the code, compare the results. And then I will explain why we are getting the results that we are actually getting in reality. Okay, we got number 1 as a result. So, do you know why this is happening? Okay, I will explain it either way. So, the reason why we're getting 1 is because when we divide 31 by 5, the clean division, so to say, would be 30 divided by 5, and that is going to be 6. And remainder that is left from 31 to 30 is 1. So the modulus is going to be 1. So let's extend that basic understanding a bit more by going through another example. And again, I'm going to use example that we covered in the discussion about division. So we are going to be using 34 and dividing it by 5. I mean, using modulus by 5. And when I run the code, what do you think we will get? I'm sure that you got it right this time. We got 4. Because again, when we divide 30 by 5, we get 6 as a whole part, so to say. We would get 6 as a result of division. And the remainder of division is going to be 4. Because 34 minus 30 is going to be 4. And one last thing I want to show you is the fact that modulus works with floating point numbers as well. So I will be using exactly the same example from before. And as you can see, the data type is specified to be F32. And when I calculate the modulus from number 31 and use number 5, we will get the result 1. Which is exactly the same in the scenario where we were using integer values. Which basically means that we managed to cover all the basic arithmetic operators in a single video. Of course, if you have any questions or concerns, please feel free to leave them in the comment section of this video and I'll try to address them all. And now, my dear friend, I would like to congratulate you on the fact that you managed to stick all the way till the end of this video, because it's a lengthy one. But at least I hope it was worth the struggle and pain of listening to me for this long. If you found this video enjoyable and useful, I would like to invite you to please subscribe to this channel and like this video, because it would help both me and the channel to grow and spread the word about Rust programming language. And for that, I would like to thank you in advance. In our next video, we will be finally finishing our discussion about operators. So it's going to be the third video where we are going to be discussing operators in Rust. And in that video, we will be focusing on some comparison operators that we will be using a lot in real life, and also some assignment operators that are also very commonly used. So our next video is basically going to be something like the end to this whole era about operators in Rust. And now there is only one thing left, and that is for me to wish you an amazing day. Goodbye!